Back everyone. In this lesson we're going to look closely at table B, cooling windows and doors. This table is an important part of the manual J process because it helps us understand and determine the solar heat gain through windows and doors. So again, we're using these charts and tables to help us calculate the cooling equipment size. We can't just throw any size of HVAC equipment on a building. We have to size or gauge the amount of heat they're going to be absorbing or adding during the summer or the winter. But in this case, we're going to be focusing on the heat gain to the windows. So let's start with the outdoor design temperature. So table B gives us values based on design conditions of 90 degrees, you can see right here, 95, 100, and 105. Now you'll notice that each kind of glass will have its own temperature outside design condition for that type of glass. And then based on that temperature, you're going to have the solar heat gain multiplier for that temperature. So you could see the double glass has a 90, 95, 100, 105. The triple pane glass has 90, 95, 100, and 105 as well. Think of this as a reference point for the climate you're designing for. For example, in a mild climate where summer design temperatures is like 90 degrees outside, the solar heat gain values are lower. You'll see those numbers here. Versus in a higher climate, so let's say Phoenix or even Kern County, where the outside design temperature is closer to 105, the table shows a significant higher heat gain. You can see these numbers here are a lot higher than an outside design temperature of 90 degrees. And the adjustment is important because as the outdoor temperature rises, the cooling load from the windows and doors will rise as well. So it's very important that we pick the right temperature for where our home is located. And most of the time in Bakersfield or Kern County, we're going to be choosing the 105 degree temperature. So this chart is for pretty much all houses around the globe. But here in Kern County, our outside design conditions are going to be around 105. It's going to be our pick. Now let's talk about the sun direction in table B. So table B accounts for whether the window faces north, south, east, or west. Now why is this important? Well, the east and west facing windows usually show the highest solar heat gain because they get direct low angle sunlight in the morning or late afternoon. So if you didn't know, hopefully we all do, that the sun rises on the east, and so the sun rays are coming in from the east and it sets on the west. And as that sun begins to set on the west, that solar heat is going to come from the west. So your east and your west are going to get that most sun heat gain against the window. Now, south-facing windows get strong sun in the midday, but the higher the angle makes for shading more effective. Now, north-facing windows usually get the least heat gain, and you'll see that over here. There are different directions of the sun against the windows. So if we have windows that are north or shaded, then we're going to pick this category right here, depending on what type of glass we have. And we'll go over this more detail in a minute. If our east and west, if you notice our east and west facing windows, they have a higher solar heat gain in that section. And the numbers drop because as you move to the right of this chart or table, you're going to be increasing in efficiency depending on whether you have double pane glass or triple pane glass. So, and then you have your south facing windows. You got your numbers here, double pane glass numbers here, and triple pane glass numbers here. And then the southeast, southwest, or northeast and northwest. Typically in this, the projects for this class, we're going to be doing north, south, and east and west. We're not going to be doing anything too crazy where northeast or southeast. We'll just stick with these three categories of direction. Okay, now let's talk. We're going to review really because we talked about it in the heat loss table A, but in this one we're actually talking about gain, heat gain. We're adding heat to the building. So window glazing in heat gaining, we have different values, and when we have a single pane glass, double pane glass, or even a triple glazed window, work just like the wintertime, right? So single glazed windows, that's just one pane of glass, one sheet of glass, allows the most heat gain into your home. Now, double glazed windows provide much better performance because they have two pieces of glass. They provide an extra layer of glass. Plus, that airspace in between those two pieces of glass reduces the amount of radiant heat transfer. The triple pane glass windows are the most effective at blocking heat, and they show the least values in the table as far as heat gain goes. You see your triple pane glass, you can see these numbers are very low. So those are the most energy efficient windows, a triple pane. Double pane is efficient as well, but the single pane glass are the least efficient, energy efficient windows. So this means if you're designing for your home with a single glazed window, you calculate a much larger cooling load compared to the one with the modern double or triple pane glazed windows. So when we're using table B, we look up values but combine three things, right? So we're looking at this table, we're looking at three different things. We're looking at the outdoor design temperature for that location. Again, and we can get that number based on our design conditions, right? Because our design conditions from ASHRAE's website will tell us what's the average temperature. We're going to gauge our outdoor design conditions based on our design conditions. And that's how we can select our outdoor temperature right here in this section here in green. Now, the second thing we're going to look at in this table, or we're going to choose from, is going to be the orientation of the window. And that's the direction right here. And the third thing is going to be glaze type, or how many pieces of glass are in that window. Single, double, or triple. So to wrap this up, table B is going to be a go-to reference for understanding how windows and doors add to the cooling load. We're going to see how many BTUs, depending on how many windows we have and the size of those windows, how much BTUs we're going to gain from those windows, because we're going to take that multiplier, we're going to times it by the area. What's the area of the windows? We're going to add up all these BTU gains, and we're going to have to figure out a total for all the heat gain we're gaining through the windows and doors. All right, so always remember, the higher the outdoor temperatures, east and west exposure, and a single glazing mean higher heat gain. Lower design temperatures, north-facing windows, and double and triple glaze mean lower heat gain. So in our next video, we're going to do a practice where we apply some of these numbers and fill in the chart. These numbers are going to be hypothetical. It's just to help you assist you for your future project for the class. If you have any questions regarding this overview or summary of this table, just shoot me an email, or you can ask me in class. Other than that, you guys have a good night, and I'll see you later. Thank you.